Hi everyone, welcome to lesson 2.8. Today we're going to be looking at the chain rule. So far we have seen the power rule, the product rule, the quotient rule, and how to take first order derivatives of trigonometric, exponential, and logarithmic functions. But today I want you to think about composite functions. So this would be a function like y equals the square root of x cubed plus 2. So in this case, we have two functions that are composed. First is the square root of x. You can think of that as the outside function. And then in place of x, we've substituted the cubic x cubed plus 2. That's my inside function. Consider y equals sine of x squared. This is a composition of the two functions y equals the sine of theta and y equals x squared. And so what we're essentially doing here is just taking a function like x squared and plugging it into another function, in this case sine of theta, letting theta be equal to x squared. But this leads us to our inquiry question for this lesson, which is, how do you take the derivative of a composition of functions? Well, one thing that you can do is use substitution. And so what we'll do is we'll let u equal g of x. And then to find f of g of x, we just simply have f of u. And let's say that I differentiate each of these using Leibniz notation. That's the dy dx notation. So we have y equals f of u. Well, dy, and what's the variable I'm taking the derivative with respect to? In this case, it's u. So dy du is equal to f prime of u. And let's do u. So here we have u equals g of x. And so taking the derivative, we have the derivative of u with respect to x. And that's going to be g prime of x. Now, what is f prime of u? Well, f prime of u is really just f prime of g of x. How do I know that? Well, because u is equal to g of x. So what we have in Leibniz notation is dy dx, the derivative of y with respect to x. This is the derivative of the composite function. That is going to be dy du, which is f prime of g of x, times du dx, which is g prime of x. And so out pops our chain rule. Now, this is just another way of writing it using Leibniz notation, but it is very handy. I will point out, however, that the du's don't cancel out per se, but thinking about them in that way will always help you set this up correctly. All right. So let's skip ahead and let's take a look at our first example. So in this case, okay, so here we're going to be taking the derivative of f of x equals 5x plus 3 quantity squared. Now, in the past, we've done derivatives like this. In fact, we can do this without the chain rule. Let's take a look. So I've got f of x is equal to 5x plus 3 quantity squared. And so the first thing that I need to do is expand this binomial. And so one way that I could do that would be to certainly FOIL 5x plus 3 against itself, but that's kind of time consuming. Here's a fast way to do it. I'm going to use the perfect square trinomial formula. A plus b quantity squared is equal to the first one squared plus the product of the two doubled plus the last one squared. And so here f of x becomes 5x quantity squared plus the product of the two doubled. That would be 3 times 5 is 15, x times 2 is 30, x plus the last one squared is 9, so this is 25x squared plus 30x plus 9. Now, all that remains is to take the derivative using the power rule, and we will do this to each term in our polynomial. So f prime of x becomes power times base down 1. 2 times 25 is 50x plus 1 times 30 is 30 times x to the 0 is just 1, so I have 30 plus 0 because the derivative of a constant is 0. And so here is my f prime of x, 50x plus 30. Now, what would this look like if we used the chain rule? Well, so let's start with our function again. F of x equals 5x plus 3, quantity squared. And no need for me to expand this binomial squared. All I need to do is go ahead and take the derivative. F prime of x is going to be equal to the derivative of the outside function. So the outside function is essentially x squared. And so that would be 2 times x. But in this case, x is actually 5x plus 3. That's my inside function. I'm just going to leave it alone. And power times base, which is 5x plus 3, down 1, and that's what I've got. But now I'm going to multiply by the derivative of the inside function. And the derivative of 5x plus 3 is just 5. So now I can just simplify. 2 times 5 is 10, and 10 times 5 is 50. 50x plus 2 times 5 is 10, 10 times 3 is 30. And there is f prime of x using the chain rule. All right, why don't you take a moment and see if you can work example 2 before watching the next video, and then we'll come back and we'll check example 2 to make sure you've got it. See you in a moment.